So being born in the family of a surgeon, Mr. Varun has a deep interest in healthcare and technology from his young age. So he spent several formative years studying chemical and biomedical engineering and technology hub, Carnegie Mellon University, Pittsburgh, Pennsylvania. He then went on to work on implementing digital health in India and the United States, helping vulnerable populations through care coordination and systems approach to healthcare. While in the United States, Mr. Varun learned about effective altruism, a philosophy which seeks to investigate and target the world's most pressing problems. So he came to understand the tremendous impact of industrial animal agriculture on the world and the imperative need to transition away from it using markets and technology. So in dedicating his work to the future of protein and combining his duty to human and planetary health, Mr. Varun aims to help build a healthier, sustainable, and global food system starting right here in India. So Mr. Varun has spoken at various conferences and universities all over the world, ranging from the Indian Institutes of Technology to the Harvard University, and his writing has been featured in media, including the Hindu, First Post, and the Daily Guardian. So with these few words of introduction, once again, I would like to welcome Mr. Varun and Chandana to NABI and SIAM, and I would like to invite Mr. Varun to deliver his talk. Varun, please.
Thank you so much, Dr. Kanti, and thank you everyone for being here. I want to thank Dr. Mantri as well, Dr. Parikh, who is hopefully online, but even if he's not, we've been in touch for over a year now, almost exactly 1 year. And the faculty and leadership at NABI and SIAB have always been very supportive to us, Dr. Rishi as well. We've been in conversation for a year because we were actually brought together by officials at the Department of Biotechnology. And I think this is the culmination of a number of discussions we've had over the last year through a lot of different challenges. And I think it's really exciting for me to be here today. So I'm going to be speaking today about the work that we do at the Good Food Institute to advance an exciting new area called smart proteins, also known as alternative proteins globally. We believe that this can be a key pillar of India's 21st century green economy. And some of the work that we've been doing, I think, will be quite exciting to people in the room here as well. Dr. Kanti very kindly gave that introduction. I should be clear, I was very much not a good engineer. He mentioned chemical and biomedical engineering. I think my tenure in the US studying those things underscored for me how important those things are, and also that I'm not meant to pursue those things. So I have a deep degree of respect for everyone in this room and how you're kind of taking forward technology and the status of India at the center of that landscape globally. So just a quick introduction to us. We're actually a non-profit organization. We're not a private limited. We're part of a global network of nonprofits. We advance this shift or this protein transformation to a more secure, sustainable, and just food system through a few key areas. You can think of them basically as science, business, and policy. We work with universities, we work with companies, we work with government agencies, pretty much anyone who can help us transform the protein supply. And we have partner organizations in this Good Food Institute network in Israel, the United States, Brazil, Europe, and Asia Pacific, primarily based in Singapore, but now we're also setting up in Japan and Korea, etc. Okay, so now for the important stuff. I think everyone in this room, when you're dedicating your careers to this area of food biotechnology or bioprocessing, this area of work, I think we all share this important motivation, which is figuring out how we feed 10 billion people by the year 2050, over 1/6 of whom will be in India still at that time, right? And one of the challenges that we have in doing so is that we have a lot of resource scarcity, right? So we have to innovate ourselves out of these challenges, and anything that we do to set up a future food system has to ensure that it is sustainable, efficient, and safe. Now, unfortunately, one of the areas that we need to focus on in this landscape is our supply of protein, which currently primarily comes from, or is seen to come from, the large-scale raising and slaughter, and even hunting, in the case of fishing, of animals, right? Now, I'm not going to go into each of these statistics here because actually they've become increasingly well known over the last decades. But essentially, industrialized animal agriculture is one of the primary challenges. It is both our supply of as well as a challenge to the supply of protein globally. So as an example, people at the Intergovernmental Panel on Climate Change, the FAO, the Food and Agriculture Organization of the United Nations, the Eat Lancet Commission, all of these people who study these things day in, day out, say that when it comes to deforestation, land use, water use, greenhouse gas emissions, ocean dead zones, ocean acidification, biodiversity loss, species loss, all of the things we care about under the umbrella of climate change, industrialized animal agriculture is one of the top 2 or 3 causes of all of those things. As an example, it accounts for more climate change than all the emissions from the transportation sector combined. Similarly, we're also feeding about 70-ish% of all antimicrobials globally to farm animals as opposed to humans. And I think we know what happens. I think that's an area of huge focus now currently within the One Health approach, right? And all of this is very simple. The reason for it is because we have this organism, an animal, which while it concentrates a lot of nutrition, it is in fact an inefficient protein production platform, right? So a chicken, which is the most efficient animal that is farmed for meat, takes in about 8 or 9 calories to give you 1 calorie out in the form of flesh or meat, right? So we're using huge swaths of agricultural land, water, emitting huge greenhouse gas emissions, using huge amounts of antibiotics, etc., to get these returns. And this is something that's been identified as something we need to diversify. Also worth noting that India is particularly susceptible to all the issues I just put up here, right? So this is from Deloitte. They say we stand to lose about $35 trillion by 2070 to climate inaction. We also have it. These are stats from Niti Aayog. We have about 600 million people living under extreme water or high to extreme water stress today in this country, which will only grow. We have many of our major cities running out of water, reaching day zero of water by 2030. And we also have these challenges in the developing world that are more acute when it comes to food safety and public health, right? So on the bottom right there, you'll see low and middle income countries have about 41% of the world's population, but we suffer about 75% of the world's foodborne illness related deaths. So huge challenges. We're particularly vulnerable to all of these things, right? And of course, we're all at this moment in time hyper acutely aware of the dangers of things like zoonotic disease, pandemics, antimicrobial resistance, etc. Now, I've said all of this stuff, and I think we all know them to be true. So now that I've said all of this, I think everyone here who eats meat, eggs, dairy is going to go home and stop eating those things, and the problem will be solved forever, correct? Yes, no, obviously not, right? That's not going to happen. Why? Because meat is delicious. It brings people together. It's full of protein. It's nutritious. It's aspirational. And that's what this reflects, right? I think in every country in the world, as incomes rise, we see a massive upswing in meat consumption. So while Indians don't actually consume a lot of meat from a per capita standpoint, we're actually seeing an uptick in meat consumption that is going to continue. So regions like South Asia, Southeast Asia, eventually even Sub-Saharan Africa will have a much larger meat eating footprint and therefore a much more acute climate impact, which will be felt locally as well as globally. So as I said, 71% of India's people self-identify as non-vegetarian. Actually, this is from National Family Health Survey 5, which is 2014. So this is already out of date. It's now 77% from the National Family Health Survey 6, which was released this year. We also know that we rank highly when it comes to production of these commodities, which is good for our economy, right? It is one of the things that we export. And now we need to make sure that we are supplementing this with additional sources of protein. And then finally, just to identify one of the vulnerabilities that exist, maybe during the pandemic, you were also following this. And this happens all the time, there were periodic outbreaks of zoonotic disease, right? So when there are outbreaks of zoonotic disease like avian flu, etc., the people that suffer most are not you and I. I mean, we'll receive a message on WhatsApp saying there's an avian flu outbreak and people will be a little afraid for a few days, stop eating chicken for a few days and then go back to it, right? The people who suffer the most are in fact the smallholder farmers because they have to dump their entire stock of chickens at that time. So 4,000 chickens, 7,000 chickens at a time are culled. We actually see how drastic that this could be in a place like China. We've seen it over the last few years where they've got African swine fever, which has absolutely decimated their population of pigs. So something like 60% of the pigs in that country, which is by far the largest producer of pork on this planet, have either died or had to be culled due to African swine fever. And their economy is so dependent on pigs that they jokingly call the consumer price index, the CPI, the China pig index, right? So the economic vulnerability of these things is extremely high. And for us, with our smallholder population of farmers, it's very important that we create some resilience to all of this. So our approach, and the approach within the broader smart protein sector, is not to tell people to eat to eat chickpeas instead of chicken, or to eat moon beans instead of mutton, or to eat broccoli instead of beef, because obviously that doesn't work. The idea is, can we provide a solution that tastes the same or better and costs the same or less? So it feels like a simple switch, not a sacrifice. And that's for the consumer as well as the producer, right? So the idea is to perfectly replace the sensory and the cultural resonance of meat, eggs, and dairy, or to supplement it, right? So this is where smart protein comes in. It's a sunrise sector that encompasses a few categories of foods, but the idea is exactly what I said. So we have this promise to diversify the existing protein supply, but we won't do it without satisfying taste and cost and accessibility. So these are the categories of smart proteins. There are plant-based foods, there are fermentation-enabled proteins, and I'll get into each of these. And there's cultivated meat or cultivated proteins. And important to remember that, while there are 3 different categories, we're already seeing this as a spectrum, right? So you're seeing, I'll talk about this a little more, but there could be fully plant-based meat. So I've put tofu on the screen there, but we don't think of tofu as a plant-based meat substitute, but let's say a fully plant-based meat substitute. And then all the way on the right, you could have a fully cell culture derived product. But in the middle, there are things where people are already producing hybrid products. So taking cell culture derived ingredients, blending them with a plant-based product, etc. And that, of course, creates a number of different interesting questions from a regulatory standpoint, from a distribution standpoint, all of that. As we've been working together, with Dr. Parikh and with NABI over the last year or so, we've also been able to identify that there are these various opportunities that can exist for India through all of this, right? So agriculture and allied development, sustainable development goals, climate, nutrition, security, etc. I won't go into all of this. Okay, so diving into it, fermentation, I think everyone knows, you're all students, scientists, PhDs, etc. So you know it better than most people, but if you've ever had beer, yogurt, kimchi, everyone knows what fermentation is, right? So while it's been utilized in food applications for a very long time, and especially in other industrial applications for a very long time, we mean a very specific thing in the smart protein sector when we say fermentation. So there's 3 different types of fermentation that are being leveraged, but all of them utilize microorganisms to do something with food naturally, right? So there's traditional fermentation where people are using microorganisms to modify plant proteins, to bioprocess plant proteins to be more functional, nutritious, etc. There's biomass fermentation where people are growing the body of the microorganism itself, like the company Quant that Dr. Kanti was talking about to me earlier. And then there's precision fermentation where you're using the microorganism itself as a production factory. So you coach the microorganism to produce a protein of interest, which could be a egg albumin protein, etc. So some examples on this, there's a company called Mycotechnology in the US, which is using traditional fermentation to improve the nutritional and functional qualities of plant proteins. So plant proteins by themselves might have some off taste, or they might have some functional challenges. They don't perform exactly the same as animal protein in an end product, right? So the fibrous texture, the specific nutritive qualities, etc. Mycotechnology has figured out ways to take plant proteins like pea and rice protein and turn them into something that is more functional in an end product. And they actually partnered with JBS, which is by far the largest animal meat company in the world, to launch a line of plant-based meats based on this. Here are some other examples of biomass fermentation, which I mentioned is the second type. So where you grow the microorganism itself and then process it into end product. So I mean, if you look on the screen there, this really looks like the end product, right? So on the left is, maybe I can't really see the angle here, but on my screen, it looks very clear. That really does look like a steak, right? In the middle there, you'll see what looks like a chicken breast. On the right, you'll see what looks like bacon, right? So these are really going far beyond the previous generation of soya nuggets. They're really, this is why we call them smart protein and not mock meats, or or any of the traditional products that have been available in India and China for millennia, because this is really going far beyond that. And then finally, examples of precision fermentation. You'll see there, I mentioned an egg ovalbumin on the left that's been used to create some sort of gel or meringue. In the middle, you see, or going from left to right, you see Perfect Day, which produces beta-lactoglobulin from microorganisms. You see Geltorch produces gelatin, you see heme proteins, and then you see growth factors, which I'll get to. The second category that we talked about is cultivated meat. Now, this is the use of cell culture of animal cells to produce meat at large scale. So this is a bit different. Obviously, this is actually using animal cells, so it's biologically identical to meat. So if you are vegetarian, you would not, if you're a strict vegetarian who doesn't want to consume any animal product, you would not be able to eat this, right? It actually takes what has been done in cell culture labs for decades and provides a food lens on it. So the scale that it needs to be produced at is much, much larger, orders of magnitude larger, right? And the idea here is because it's authentic animal cells, they would be expressing everything that those cells express inside the body of an animal. So you'd get a much closer sensory and nutritional profile to authentic animal meat. This is what it looks like to produce cultivated meat at scale. So on the left there, you'll see there are cell lines, there are cell culture media, there are scaffolds, and then there are bioreactors or fermenters. These are the kind of 4 technology elements, and optimization is needed or possible across all of these, right? So if we wanted to produce, for example, a chicken, cultivated chicken, you would be deriving the cells from a chicken, right? No slaughter is needed. If in fact we could take heritage breeds of chicken, like a Kadaknath chicken or something, and produce Kadaknath cultivated chicken, which is really interesting. And obviously, when we say optimization is possible, you'd be looking at various traits within those cell lines, things like multi-generational stability, yield, all of those things you need to optimize for, right? Then you have the cell culture media, which, as we know, is the consumable component, which might get very expensive at these large scales. So really optimization is needed there. Some of the ingredients in cell culture media, which are the things that are consumed by cells inside the body of an animal, salt, sugar, amino acids, etc., those can be sourced maybe at food grade prices, but there are other things, growth factors, signaling molecules, etc., that signaling proteins, etc., that need to be sourced currently at pharmaceutical grade. So the cost is very high. So as of now, this contributes maybe 80% of the cost of cell culture in cultivated meat. Then you have, you want to kind of proliferate, so the cells are differentiating into the kind of 3-dimensional matrix structure that exists in animal meat, right? You have fat cells, you have muscle cells, you have connective tissue. So you might want to do that on a scaffold. This again is a well-known concept within the biomedical world. Those scaffolds could be made from biodegradable materials or from food grade materials, alginate, chitin, etc. There are many different things that could be used. And then finally, you have the bioreactor or the fermenter, right? So once again, bioreactors or fermenters are used in industrial biotechnology a lot, but here we're talking about an application where we need to scale that up to orders of magnitude greater. So this is really the 4 technology elements, and optimization is needed or possible in all of these. What's been happening in this cultivated meat space is really interesting. And again, this is just one of the 3 categories, but in 2013, a Dutch researcher by the name of Dr. Mark Post, he has a long history of regenerative medicine work. He cooked and ate the first cultivated lamb patty on TV. And it was funded by the Dutch government and Sergey Brin, who's the co-founder of Google. And the research project was about $330,000 US. So of course the media picked that up and said, this is a $330,000 burger. So let's take that data point. Of course, we know that's not what the actual burger cost, but let's take that data point. You know, about 8-ish years later, last year, Dr. Mark Post was, he has a company in the space now. He was on TV or on the radio, and he said they're now producing those. It's not launched in the market yet, but they're producing those for an internal cost basis of about €9. So from $330,000 down to whatever that is, 10 USD, right? And that's what we know happens when you start applying more of a scale-up lens to all of these things. The challenge here, of course, is coming down from $10, which is still very expensive, to $1 or $2, which is the actual price of a burger patty. We've seen some major growth in this area since 2013. So a few years later, in 2016, was actually when the first company was incorporated in the space. And now, we've seen, let's say, the last circle there is 2020, but in 2022, there'd be 100+ companies that are in this space, including a couple of them in India. Interestingly and very excitingly, you also have on the bottom left there, cultivated meat is now available for sale in Singapore. It's only from one company for now, but the Singapore Food Agency has approved this for sale. So it sounds like science fiction. It still sounds like a scientific experiment, but you can go to Singapore and you can actually consume cultivated meat from a couple of different sources. Okay, and finally coming to plant-based meat, which is the category with which people would be most familiar actually. But once again, I want to reiterate, this is not our grandparents' soya nuggets. It's not the soya chop that's available everywhere across the north, right? And which is very popular and rightfully so. But the idea here is it's meant for non-vegetarians. So if you know what juicy, fragrant animal meat tastes like, and you know the organoleptic differences between a pomfret and a bhangra and a bluefin tuna, this is what we're talking about, right? So the idea is using plant or crop ingredients to produce something that provides the sensory and the cultural resonance of animal meat. And there's various different types that have been utilized, roughly ranging from easier to more difficult. You'll see the restructured products that are made from mince on the left, like a burger patty or a sausage, are much easier to produce than what is there on the right, which is kind of a holy grail whole muscle cut of plant-based meat. And so there's a lot of different dimensions of product development improvement that are happening across this realm. But just to give you one example, there's a company in San Francisco called Eat Just, which makes the Just egg. The primary ingredient is mung bean protein isolate. And that mung bean has been eaten on this subcontinent for 4,000 years, as you would all know. They've sold this the number on the bottom of the screen is vastly out of date. It's closer to, I think, about 220 million eggs now. Eggs, 1.5 ounces of liquid is considered an egg by them. And it uses 98% less water, 83% less land, releases 93% less CO2. Plant-based dairy also well known, and I'm going to get to the Indian sector shortly, but these are some examples globally of kind of what's been happening. So you have different ingredients that are being utilized: pea protein, coconut, tapioca, almond milk, etc., as we all know. And this is what I showed, the kind of cultivated meat production value chain. This is what the plant-based meat production value chain looks like. So this is, I think, very relevant for many people here. But essentially, there is a right from the crop all the way through to the end product. So the crop through to protein extraction and functionalization, through to ingredient processing, through to end product formulation and kind of distribution. There's many opportunities to optimize here. So, you know, when it comes to the crops, we are still utilizing in this space crops or ingredients that were optimized decades ago for some other purpose. So either for the edible oil industry or for animal feed, etc. So oftentimes what you see is that result that has an impact on the end product formulation all the way through. Because if I'm using a soya bean protein isolate, but that protein isolate or that flour that I'm getting from the soya, the defatted flour, simply does not have the functionality that is needed in an innovative end product application like this, then I have to add a lot of additives, right? So that creates a less clean label end product, which might affect the consumer perception, right? Also, there might be inherent off notes, grassiness, taste is affected. There might be inherent nutritive qualities that are affected. And we all know that all of these things are actually artifacts of the same thing. It is the kind of molecular level signatures which lead to the functionality, which lead to the end product taste, nutrition, et cetera, et cetera. So there's a lot of variability within the plant kingdom. There's about 392,000 plant species. I could be off by a few thousand here and there, but I'm sure you'll forgive me. Within chickpea, for example, there are chickpea species or varietals, in India that have 22% protein in them. There are chickpea varietals that have 11% protein in them. That's a vast difference, which has a huge kind of make or break economics implication, but there's also functionality and taste and all of those things that are affected. So this is kind of where we're trying to optimize across this area. Yeah. So, you know, these are the things that we might do together or as a scientific community. These are the kinds of things that are happening globally. Forgive me if the text is a little small, but once again, I think right through from kind of crop optimization through to kind of isolation and functionalization, formulation, processing, distribution. You know, I'll take another one of these nodes. If you look at, let's say, isolation and functionalization, once again, traditionally what has been done is optimization for yield, but now people are looking at things like sustainability and functionality, et cetera. So if you use a solvent extraction method to take the protein out, to fractionate the protein, it might have an impact on the actual functionality of that protein, right? Which impacts the end product. It also has, you know, I mean, hexane and other solvents that are used, then you have to dispose of those solvents. So all of these things are things that maybe require an interdisciplinary lens. Each scientific group cannot work without the other to optimize across this entire value chain. So that's the kind of things that we hope to do together is, work with NABI and CIAB, as well as bring in other institutes that might have different complementary areas of expertise. Similarly, going back to fermentation, I think very relevant to CIAB's work, there is a lot of optimization that's possible. I think everyone globally thinks of fermentation as having glucose as a feedstock, but that's susceptible to kind of market fluctuations in the price of glucose. We currently have a glut of glucose in this country, so it could be used as a feedstock, but we need to perhaps create other feedstocks or optimize for other feedstocks, find different microorganisms. So many of these companies now are starting to actually file IP on the microorganism itself. So Quon, the company that pioneered some of this work, they had a patent on Fusarium venenatum for about 40 years. It came off now, right? But they've had that patent for a long time. So I think optimizing on different dimensions, finding the right microbe, figuring out how to produce in these agroclimatic conditions, environmental conditions, what are the feedstocks, integrating into the agri supply chain, because many of the things that are seen as waste, things that have received a lot of criticism, unfairly or fairly, things like stubble burning, etc. A lot of that agri waste could actually be used as feedstocks into this, but we need to figure out how that works, right? Okay, so the good news is we've done some of the life cycle work on this, and many of the companies have as well. Let's assume the companies have their own vested interest. We've done some of the life cycle work on this through third parties, through governments, etc. And we see that, as far as the environmental opportunities, there are massive opportunities here, right? So as a diversification, we can definitely create huge environmental benefits in terms of land use, water use, pollution or effluents, greenhouse gas emissions, etc. There are orders of magnitude improvements that can exist. We also know that it's actually vastly undercapitalized. So if you look at the bottom of the screen there, second from right, that 11 billion figure is the amount that's been invested globally into this area of smart proteins over the last 11 years since it's basically existed, right? Sounds like a decent chunk of money, right? Most of it has come in from private venture capital style investment because that's what drives the market. It's gone into all of these companies. But if you look at renewable energy in half the time frame, a 6-year time frame during the same period, it's got nearly $2 trillion, right? Which is many orders of magnitude greater. And that's rightfully so, right? Climate is one of the biggest challenges of our age. So an energy transition is exceedingly important, and it's important that it's received that type of funding. But to come to equivalence there is what our opportunity is in this space. And that needs to come from different types of funding. If we get it right, there are all sorts of estimates for what the market can reach. There's a number of different estimates on the screen. Don't expect it to retain any of this, to be honest. But on the top right, you will see $1.1 trillion by 2050. That's kind of the high end, what's possible to achieve. And theoretically, it makes sense because if you look at meat as a global landscape, it's about $7 trillion today. So by 2050, it might be what, $10 trillion, right? And if we're able to capture a slice of that, that would be a huge opportunity. We also have a specific set of opportunities in India that I think we can now speak about. We have this, I don't need to tell anyone here, we have this massive crop biodiversity that is under leveraged currently. We're still utilizing the same commodity crops for the most part. If we're talking about pulses, millets, pongamia, hemp, all kinds of different opportunities on what can be utilized in this space. And one for the same priorities I mentioned earlier. So better taste, better complete nutrient profile, not just macronutrient, but also micronutrients, etc. We have a globally competitive talent pool. If you look at any of the founding teams through to C-level management, VP management, all the way through to line R&D, it's just chock full of Indian talent, which is great. That's a point of pride for us as a country, but we would like to, it's a pretty new industry. I mean, it's existed for about 10 years. We'd love to prevent a brain drain in this industry, as has already happened in a bunch of other industries, right? So if we can, I think, provide opportunities here for people, we'll be able to create something really special. And then we have this major industrial opportunity. So it aligns with a lot of different things that government, industry, academia are already focusing on. So if you go and talk to anyone related to India's bioeconomy and how large it's become, it's $80 billion, it's going to become $100 billion in the next few years, et cetera, et cetera. This can be one of the pillars of that. Okay, coming to some of the more fun stuff. So in India, smart protein sector has been rapidly expanding. We've existed for about 5 years. Most of these companies have been founded during that time. In fact, many of them over the last 2 years. during the pandemic. So we have experimentation that's happening during the pandemic, ingredients that are coming from Berlin to Bombay to Babalgao, and like lots of different exciting things that are happening. We see about 60 plus companies now that have launched about 250 products in the market. I hesitated there because the number could be 65 and I wouldn't know. I'll have to go and check with the team. Things are changing that rapidly, right? You have companies, I'll just mention there, Blue Tribe Foods, Imagine Meats, Good Dot, Greenest, Shakahari. These are companies that are becoming quite prominent, and I'll mention why in a couple of slides. And you also have, interestingly, ingredient suppliers on the bottom right there, who are doing what I mentioned earlier. So they're using India's agricultural biodiversity to produce ingredients from it. So functional blends of plant protein ingredients that contain millets and pulses and other things. We also have 80 plus value chain partners that have been established now, ingredient players, equipment players, co-manufacturers, pilot facilities, distribution, research institutes, etc. And maybe one of the fun aspects of our work is the category creation and awareness piece of it. So we work with the companies and link them to some of these celebrities whom, as we know, can drive the market in India. So on the top left, there's Anushka Sharma and Virat Kohli, who are working with Blue Tribe Foods. They're investors and brand ambassadors of Blue Tribe Foods. Right below that, you will see an ad that ran during the World Cup, the Cricket World Cup last year. Shah Rukh Khan announced the launch of Imagine Meats, which is a company founded by Ritesh and Janelia Deshmukh. So again, lots of category awareness being created there. Right below that is Neeraj Chopra, who is an ambassador for Good Dot. One thing I couldn't put on here, which I should have edited the slide to put it on, is a couple of weeks ago or about a month ago, Shakahari announced Mahendra Singh Dhoni as their investor and brand ambassador. And then on the right there, I mentioned distribution earlier. Some of the things we've been doing is working with people like Zomato and Swiggy. Swiggy has Instamart. I don't know if many of you would know, but they do about 15 million deliveries of groceries a day on this Instamart platform. We worked with them to create don't know if you can see it on the screen, but this is their meat category, and we created a plant-based meat button in the meat category. So it's seen as a specific subcategory of meat on the Swiggy Instamart platform, and you can buy some of these products there. But as I said earlier, I mean, that 11 billion figure I said earlier is on the left of your screen there. This is not to scale because it wouldn't work if it were to scale. You wouldn't be able to see the number on the right, which is India's number, right? So it's actually about 12 million based on some funding that's happened over the last couple of weeks. But, even within that 11 billion figure, very little has been invested in India, right? So this opportunity that we have is to create a lot of growth on the ground in India. As I say, many of these companies were actually founded and launched within the last 2 years. So that number will tick up very fast, but this is an opportunity for us in this landscape. And just, some of the sizing we've done with Deloitte India has been to look at the economic opportunity in India. So this is the kind of stuff that governments like to see, right? So for people like Niti Aayog or the Prime Minister's office or anyone to invest in a space, they want to know how many jobs is it going to create, how much agricultural income, what is the export opportunity, what is the gross value addition across the value chain, etc. So we've done some of that work. And we're seeing maybe by 2030 is kind of an establishment phase of this on the ground. We're looking at about USD 4 billion. We did a lot of triangulation, a lot of data points, knocked it down as much as we could. We created 3 scenarios, and we're looking at about 4 billion by 2030, and crucially about 4 lakh jobs by 2030. And most of these jobs are not necessarily replacing any other jobs. Most of these jobs are jobs which are supplemental jobs, which is really exciting. Another way of looking at this, by the way, is that we have to train all these people, right? So it's a great opportunity, but we need people to enter the space and they need to be equipped with the right skills. So that's why we're grateful for the work that's being done here and hope that many of you will consider this area as an opportunity. One example of what we're doing to train those people is, and we'd love to talk to faculty and students here, is something called the Smart Protein Project. So it's actually part of a global network of student groups that GFI has created globally. So all of our partner organizations, it started in the GFI US organization, but we have these groups all over the world. So these are the 20 new student groups that started this year, in addition to 16 that already started last year. So we have about 36 of them, 34 of them are still active, including obviously all these 21 that just started. And one of them is a group at the University of Delhi, which will expand to include other universities in the Delhi region. So we're actually calling it a Delhi Smart Protein Project. which will include IIT Delhi, NIFTIM, etc. And we're hoping to start many groups across the country. So there'll be a Mumbai one, a Bangalore one, hopefully a Chandigarh one. So that's kind of what we would love to do here. In terms of what other countries are doing relative to India, we've seen a lot of movement in other countries. So Singapore is seeing this as a key piece of their economic growth, climate resilience, food security goals. Just as a piece of information, they actually currently produce about 7% of food locally, and that's a huge vulnerability for them. They import 93% of food, and they would like to increase the local food production to 30% by 2030. It's a pretty ambitious endeavor. Naturally, they've centered alternative proteins within that because you can produce locally in a much more prolific way. So they've been, in addition to what I said earlier, which is enabling the sale of novel foods like cultivated meat, first country in the world to do that, they're also investing heavily in R&D and talent promotion, etc. The USA has done some stuff. Qatar has done some stuff, interestingly. The Netherlands has been very ahead of the curve, as one might expect. Israel, once again, has been very ahead of the curve. And then I think the major important one that everyone around the world, maybe especially in India, is interested in is what is China doing. China already historically processes about 50% of the world's soy in one northeastern corridor of China. Could offer 10 other examples, right? If you look at steel manufacturing, China is literally one order of magnitude, so 10 times as much as the next most important country for steel production in the world, which is India. If you look at the steel production in any given month, China is 10 times as much as India, and India is second. If you look at solar PV module manufacturing, China produces 60% of the solar PVs in the world, all of which is to say, if or more accurately, when China gets involved in this space, they're very likely to dominate this space. And we would love for India to really invest heavily before it's kind of cornered by other countries, right? So this is our opportunity. And these are I'll stop here, but essentially these are the areas that we have to invest in if we're going to create that primacy in India. So we think all of these things are things to look at. So public, private, and philanthropic investment, these are things we've been discussing over the course of the morning, is to fund things like research and development, infrastructure, talent, all of that. We need to, I think, pool our thinking around where the funding is coming from. We need to create much more research and technology commercialization, talent development, incubation, agricultural integration, which is not something that is our particular strength, but might be at NABI because you already work with the agricultural communities, and then help to scale this industry, which is a nice, promising proof of concept. And it's lovely that Virat and Mahendra Singh Dhoni are doing something, but we'd love to make it an actual sector, an actual industry, right? So this is kind of where we are. We think there are promising initial signs, but ultimately we need to come together across industry, academia, and government agencies, regulators, other policy agencies, etc., and go essentially mission mode in this area, right? So this is something that is extremely important to our food security, our climate resilience, our collective future. And we'd love to work together with anyone in this room and any of the faculty to make this a reality. So I'll stop there. I don't know if I've exceeded my time or how much time I have left.
No, you're fine. You have
Great.
something to present more?
I do. I could always keep going, by the way. How much time?
5
do I have
minutes.
left? 5 minutes? Okay, I'll keep going. So when we talk about this national mission, this is what we've been working on with different agencies, including the conversations we were having over the course of the last year with leaders here. On the left there, you see smart protein innovation hubs. There's a manufacturing futures initiative. There's indigenous agriculture and smart protein corridors, and I'll go into them quickly. Smart protein innovation hubs are the kinds of things that we hope to do here at NABI and SIAB, which is scientific advancement, talent development, and incubation. As an example, we've been doing some of this work with ICT Mumbai, with NIFTIM, and other universities across the world, across India, excuse me, but there are similar partnerships that other GFI agencies have done across the world. There's different aspects of it, as I mentioned. R&D is really important, and our focus is to make the R&D open access to the extent possible, so the entire industry can advance. Talent development, I've already mentioned. Things like webinars, meetups, conferences that we would love to do together. Manufacturing futures, I think this is something where India has a very strong primacy in at least biomanufacturing, right? So this is something we would love to leverage in our space. We manufacture 60% of the world's vaccines, right? So I was talking about China earlier, but In India, we've shown that in some sectors we can be that world leader. And I think that should be the case here as well. So just as an example, if we had to hit 6% of global meat production by 2030 through plant-based meat. So if you remember that value chain I showed earlier, we would need about 25 million tons of texturized plant protein manufacturing globally to hit 6%. And we're very, very far away from that. So I think this is the opportunity, right? It would require investment. It would require R&D, right? So this has to come from industry, but there's a role for academia to play as well in that, because as I mentioned earlier, many open research questions remain on how to optimize for yield and environmental sustainability, etc. I won't go into all of this right now, but essentially, this is something that's possible across all three categories. So plant protein fractionation and extrusion, precision fermentation capacity. There's one company we've been working with in Bangalore for a long time named Laurus Bio, formerly Richco Life Sciences. They've got about 200,000 liters of precision fermentation capacity, which is immediately going up to 2 million liters. But that's one company, right? If we have to create this as a real food protein production system, then we need orders of magnitude more manufacturing capacity to come. So that's the opportunity we can compete within globally if we take this forward in mission mode. And then really interesting other areas, which is bottom right there. Decentralized protein production, so small fermenter units for biomass, whole biomass protein production is something that has not really been explored globally. We have in India a different agricultural model, right? We have a smallholder model that isn't the same as what exists in this highly consolidated model globally. Being completely frank, it creates its own challenges, but it's a huge opportunity if we can create the right operating model for some of these production platforms, right? So there's a lot of work to do, but we can get there. Very much linked to that is what we are calling indigenous agriculture. All of these pillars, by the way, reflect what we've been working on with industry. So there's industry buy-in to all of this, and we're hoping there will be continued academic and government buy-in to it. But once again, utilization of indigenous crops. We work with other institutes like IIMR, Indian Institute of Millets Research, ICRISAT, etc. on this, hoping to do more here as well. And then finally, smart protein corridors, which is, there are other ecosystems I mentioned earlier, Israel, Netherlands, Singapore, where there's a complementary skill set. So they don't have a lot of agricultural land. They have a lot of challenges that are not the same as our challenges, and they have complementary strengths. So we can, I think, work together on that. So we've been building, for example, India-Israel smart protein corridors for a while now. We just did a scientific interaction between Indian scientists and Israeli scientists last week, and we'll be doing much more of this. So things like delegations going to these countries, direct research collaborations, lots of things are possible. The Prime Minister of Israel, Naftali Bennett, was supposed to visit India last year, but then he got COVID. But I think if there might be a change of government there, but if their government visits as well, I think we could do some very high level official interactions to advance this, because they are definitely seeing it as something that is core for them. So we can help bring that expertise to India and share our expertise there as well. Let me just skip a few things to just come very clearly to what we think makes sense at NABI and SIAB. So yeah, I mentioned earlier, smart protein innovation hubs. This is a great place to consider doing that. So launching coursework, we have coursework that's being taught around the world, 5 universities in Israel, 2 universities in Singapore, 5 in the US, etc. So course modules in this area. Of course, a lot of base knowledge already exists, established knowledge already exists here. So there could be something very hyper-focused that can be introduced as a course module as part of the overall work that's being done. More webinars, more events I mentioned earlier. Centers of excellence, network of centers of excellence is already coming up around the country. I think we still have to figure out some of the funding aspects and work with government and private foundations to do that. But lots of, I think, opportunities that can be leveraged here. And then, yeah, so I think there is a opportunity for some focused research, technology development, technology transfer, etc. And then some broad ecosystem things as well. And of course, I'll share the slides here so we can take this conversation forward. Okay, so now I will really close. I just wanted to underline that, none of these things happen on their own. I think if we left these things to happen on their own, it would take 40 years to develop. We've seen a lot of growth in the last 5 years of our existence, and we think, the next 5 years will be more important. We, as an organization at the Good Food Institute, we're a non-profit. So we're not producing the products ourselves. Our ultimate goal is to make ourselves obsolete. So we would love if smart protein is actually a mainstream viable option. It is not alternative protein, but it's a mainstream viable option that can be chosen by consumers because it tastes good, because it's nutritious, because it's available everywhere. And that is not inevitable. There's a lot of work to do. It's certainly an exciting space. And for me personally, the 5 years that I've been doing it, it feels extremely exciting, challenging, of course, also things that keep me up at night, but certainly nothing that prevents me from waking up every day with extreme excitement. So I look forward to partnering here and doing a lot of work together, additional to what we've already been doing. Thank you so much.
Thank you, Mr. Varun. That's an interesting presentation. And now this session is open for a few questions from the audience. Yes, please, from the students. You can all help me in passing the mic.
Good morning, sir. The presentation as well as the concept was beyond fascination. Actually, I have so many things to dive into, but I'll keep it short. I was more interested to know about the concept of plant-based eggs. Is it similar to what we call as plant-based proteins, or it is a different thing?
Yeah, it's a good question. I see plant-based proteins, you could broadly consider as the ingredients that go into these end products, right? So a plant-based egg is an end product that is set up to have the scrambling capability or omelet capability of a conventional egg. So the format might be a liquid egg, or it might be even a frozen folded omelet that can then be defrosted and cooked. But the plant-based egg is something that, it was pioneered by that company I mentioned, Eat Just, which makes the Just egg. But there are companies in India, so you can look up Evo Foods makes a plant-based egg out of Mumbai. They're still coming to market, but that's what it is. So it's the idea is for people who want to eat eggs, whether it's for the taste or whether it's for the nutrition, that's the idea. And just to highlight once again, the nutrition still needs to be improved in these plant-based products. So an egg actually is considered a powerhouse of nutrition, right? So it's not just the macronutrient properties, which can be matched relatively easily, but the micronutrient properties, vitamin A, choline, etc., which are harder to match at that price point. So these are things that are happening. Yeah, so I don't know how to make the distinction necessarily between a plant-based protein. I would consider a plant-based protein an ingredient, like a mung bean protein isolate or a mung bean flour that then goes into these end products.
Yeah, since you mentioned the nutrition part, my next question was the comparison between the protein content of the egg, natural egg, dairy product, and what is derived from the plant-based egg.
Yeah, there are pros and cons, right? So with any of these things, we're taking a food science approach, and then it's a highly monitored manufacturing approach. So you can guarantee the quality, right? But then to match the theoretical benefits of an animal derived product is still going to take some more time and more research and more value chain development, etc. So I think that's where the challenge lies. It's a pro and a con. We need to still improve all of these products. So if you look, for example, at the plant-based meats, the other side, if you're producing a plant-based meat product, it by default contains no cholesterol, doesn't contain animal lipids, right? So many of the things that are challenges for people who might have diabetes, hypertension, etc., automatically go away. But then on the other side, does it contain all the micronutrient benefits of an animal meat or not? Those need to be optimized still. You can do a lot in terms of bringing down altering the fat profile, all of those things as well. But there's a lot of kind of work to do. Some of these things are now being evaluated globally. So I think, we were talking to Dr. Kanti about this as well. There are trials on corn, which is the biomass fermentation product, which shows it actually has nutritional equivalents to milk proteins. So check things like hyperamino acidosis and even things like hyperinsulinemia, etc., kind of postprandial and all of that. But once again, I think the micronutrient matching still needs to be done.
So since I have not seen such things, I am more curious about the shape of the last end product. Like it is actually an egg-shaped product or something?
No, that's really hard to do. It actually also doesn't make sense to try to match that. So a lot of these products are, that's a good note. I'll put more product photos on the screen next time. But there's that Just egg that I showed is actually a scrambled egg product, and they chose mung beans because they chose mung beans because of the specific functional profile of mung beans. So the mix of certain molecular signatures enables the fluffiness, the gelling capability of a scrambled egg. So they give it in a liquid form in a bottle, and then you use based on what you need. That's the idea. So it's not actually in the format of an egg.
Okay. Thank you so much, sir. I'll look more into it.
Of course, yeah.
Very good morning. Really very nice presentation. So basically, actually, I'm also working in vegan products, and there's one company which is related to the Epicamia, and we are developing vegan milk for them. So recently, they have launched almond milk and almond curds. We will also be contributing to the R&D. So actually, what I face in this problem is the texture. And specifically in point of the vegan protein, which is being equivalent to the meat. So now there were a few companies who are also showing interest regarding they have contacted me to prepare the vegan meat. So they have some own isolate of the fungus as the mycelia they are trying to make it. So that was it's really I really appreciate you have come and aware the students and us to be that there is a scope of this field, and we are happy to connect to us. Thank you.
Thank you. Yeah, we'd love to, support on any of those things. So we regularly connect companies directly with the research institutes to do this work. Some research institutes have done over the last 2 years. There's one in Bangalore that's done 34 research projects only in this area with us. Or once it starts, then more and more companies contact you directly, right? To the question of textured plant protein. So the texture of meat and also the specialized texture of a mutton versus a chicken versus some fish product, etc. There are various techniques, as you know very well. There's extrusion, there's other more expensive techniques that have not been scaled up globally, things like shear cell, etc. that are being utilized. All of these things usually involve the installation of expensive equipment. So an extruder, whether it's a lab scale or a pilot scale or a manufacturing scale, can be quite expensive, especially because many of these come from abroad. And as we know, that creates a lot of import duties and this, that, and the other. But there are other techniques also, mechanical elongation, that can be utilized without an extruder. And I think some companies are doing a good job of that. So we're happy to have these conversations and see how we can take it forward. Yeah. Absolutely. So an extrusion process puts a protein or a set of ingredients through a die under heat and pressure. Now the question then becomes does it degrade the nutrition, what to do, those kinds of things. There's more and more research that's coming out now that shows, for example, that processing soy, at least at the upstream level, so extracting the protein, in fact, can enhance the nutritive qualities. It doesn't have to degrade the nutritive qualities. But once again, we have to do this research, right? Otherwise, we won't be able to optimize unless we do the research. So here's my argument. In India, we should technically be able to do this better than anyone in the world. Why? Because we have some social challenges that have enabled us to create expertise in this country over the last decades, which can be applied directly here. Things like undernutrition and overnutrition, right? So the capable and obviously the availability of these crops, etc. What is the ultimate knowledge that needs to exist? It's at the crop level. So we need chickpea experts. We need mung bean experts, right? These are the things that are highly priced globally. So I think if we apply our talents into this space, we definitely could create something that is unmatched globally in terms of the scientific expertise that exists in this country.
Yeah, I don't know if you have tried cultivated meat. So can one differentiate that it is mutton, fish, chicken, pork, something like that, with taste wise? Because what I could understand that fish is cultivated by taking cells from fish. So can one differentiate? And what kind of laboratory or what kind of setup would be required for cultivation of these cell types?
I personally got involved in this space because when I was in the US in 2016, I tried, there was a company that I mentioned, the first company that was incorporated, Memphis Meats. They had a tasting, they had an official tasting for journalists and investors and all, which I was not invited to. But I tried a piece of the cultivated chicken and it blew my mind. I mean, at the time I was, I've grown up non-vegetarian all my life, by the way. I can tell you the difference between every one of these things. So yeah, it blew my mind. I could not tell the difference between that and chicken. And in fact, it tasted like a high quality chicken, right? So, once again, the issue, of course, with any food production is sometimes the quality, the provenance, all of that stuff can be challenged, right? Subsequently, I've tried maybe 15 different times, different iterations of many of these products. I've tasted fish the least, right? So I've only had it once. But yeah, I mean, it's very simple to tell that something is beef versus chicken versus whatever. And then secondly, yeah, you can't really tell the difference between that and the animal derived equivalent. And that is now at a time when it is so expensive to produce, the processing is still not fully figured out. And in many cases, what's happening is they actually, the cultivated biomass is maybe about 60-70% of what they're feeding you, and 30% to create the structure and the form, etc., is actually a plant, a regular food component that's been added. So in Singapore, the products that you can buy there from Good Meat, the company that does it, is the permission they've got is for a range of about 65 to 75% has to be cultivated, so cell cultured component, and then the rest can be anything else to lend it the structure. So if it's a nugget or if it's a satay or whatever may be the case there, right? As far as the lab that's needed, I mean, you need bench scale cell culture and that level of expertise. Going even upstream from that, you need the cell line isolation, which is a bit of a bottleneck everywhere, but even in India, right? Many of the companies globally are actually filing IP on the cell lines themselves. So this is our cell line of this thing. And then we figure out the industrial scale bioprocess based on that. So the intersection of bench scale cell culture and ideally the veterinary science that allows you to extract the cell lines. And then finally, the kind of bioprocess piece is what's needed. And again, I think we're lagging behind in this area because we have this capability, right? I mean, vaccines that are being produced in India, granted, they might not be mRNA vaccines, but many of them are biologics, and there's a lot of, MABs work, monoclonal antibodies work that's ongoing. It's currently stuck in Bangalore, but I think we can do a lot to apply that expertise directly here. We have lists of equipment that I would love to share across to you.
Any more questions? So if there are no questions, let us thank Mr. Varun for his fantastic lecture. It not only described about the need for protein-based foods as substitutes for meat-based foods, but it has also given some kind of direction of which NABI and SIAP really can look upon and associate with Mr. Varun and his company in order to achieve mission and vision.
Shared mission, our shared mission. Thank you. Yeah.
So I hope your association with both the institutes will be fruitful in the coming years, and it will show some kind of translational product which all our humankind can be benefited. Thank you very much.
Thank you.
So once again, so before we wind up this talk, I would like to request Dr. Rishi to present memento to the speaker, Mr. Varun. So this is a token of our appreciation and affection. So we have tea out of the outside the auditorium. Please join for that. And if you have any more queries and suggestions and discussions you want, Mr. Varun is available for some time here. So interact with him. Thank